So in this video, we're going to talk about a simple distillation setup. I do not have the parts in front of me, but we're going to make it work, okay? So this is usually one of the first labs you do in organic chemistry, and a lot of students have problem with setting it up, a simple distillation setup. So the first thing you want to do is locate your round bottom flask, and it looks something like this, a round bottom flask. Now, you want to typically put it in a heater pan, right? And so the heater would be just below your round bottom flask. Right? Now here's your round bottom flask with the mount on top of it. So this is your RBF. Alright, this is your RBF. Right? Now typically above the RBF you have this Y, well, it's not a Y, but it's kind of T-shaped. And it goes directly into your RBF. Right? The T-shaped tube goes directly into your RBF. Right, so your T-shaped tube goes directly into your RBF. Right, so this goes directly submerged into your RBF. Right, now this is where your condenser connects. Right, so your condenser will connect. You'll connect your condenser to this part of your T-shaped tubing. Right, and your condenser typically has two openings. Right, so it typically has two openings. So this is your condenser. Typically has two openings. Right, so we're gonna say this is your condenser. Right, now you have hoses that actually attach to your condenser. So water, the inlet hose, this would be water in. The outlet hose would be water out. Now we set this up, you want to set this up just like this because you want the water flowing through your condenser to cool the liquid vapors, or to cool the vapor to liquid. You want it to flow against gravity, right? So you want it to flow against gravity. And the reason why this is because you want to reduce the pressure that's coming out of the condenser. That way your hose or stuff like that doesn't like burst out or burst off, right? So you just want to reduce the pressure. So that's why you always want water coming in from the bottom and going out. Now, the other opening on the Y-shaped tubing, you should have a rubber stopper that has a small hole, right? So you have a rubber stopper. It's not really a stopper, but it's made out of rubber. So R-U-B-B-R. Right, so it's made out of rubber, and you simply insert your thermometer through this hole. Now here's the important thing. You want to make sure the thermometer bulb is slightly below. All right, so let's say this is a bulb or your thermometer. You want to make sure it's slightly below this. And I do not care who or what your teacher says, right? So this is your thermometer, and this is an important point. Thermometer, right? This is an important point. You want it to be just below the inlet going into the condenser because you want to get an accurate boiling point. Now, if your bulb of the thermometer is slightly in the middle, then you're going to get wrong readings, right? Because at this point, the liquid is already condensing. So that's why you want your thermometer to be slightly below the condenser inlet, or going into the condenser. So I do not care like what degree your professor has, or whatever. Like if he's telling you, or if he or she is telling you that the condenser should be in the middle, they are wrong, right? You're going to get erroneous data points. So you just want to make sure the bulb of the thermometer is below the condenser inlet. So this is the bulb of thermometer, right? So you just want to make sure the bulb of the thermometer is below, right? So you have water flowing in, and the only thing left is that you have a usually J-shape, I want to say J-shape tubing, right, that comes down. you have a J-shaped tubing that comes down into maybe a flask, right? So sometimes it's a flask. You could use another round bottom flat, right? So this is your collecting flask, right? So you want to attach the J-shaped tubing to your collecting flask. So this is the flask, right? Or this could be another RBF, right? So this could be another round bottom flask. So anything of your choice. And now you want to make sure you put blocks on your setup to make sure this is totally submerged into the J-shaped tubing, right? And that's pretty much it. Now, the only thing I want to make sure that I say here is that you want to make sure you clamp. So there's two places I usually like to clamp a distillation setup, so the setup is firm and there's no disturbances. You want to usually clamp it around the condenser, right? So just place some clamps around the condenser onto an apparatus, right? So you could have a clamp that, right? So this is your clamp, right? So you want to place the clamp around the apparatus. That gives the condenser a sturdy feel, right? So obviously the clamp is going to be something to the back of the hood, so it's going to be clamped to the back of the hood. And then you also want to clamp it right here, right? So I'll also advise to clamp it about right here, right? So another clamp around right here. Now you have keg clamps, right? So you have keg clamps that are actual plastic. You do not want to put a keg clamp around the round bottom flask neck and the bottom of the T-tube. And the reason being is because right here is hot. It's really hot, and so what happens to plastic when it gets really hot? It melts, and then when the experiment is over, all of a sudden you have a round bottom flask that's stuck to a J-shaped tube, and then right, it's embarrassment and stuff like that. You don't want that stuff to happen, right? So do not clamp this portion with a plastic keg clamp. Now, if you're at a top class institution and you have like metals, then when you could go for it. But if you have plastic, do not clamp this portion, right? A thermometer reading on a distillation setup is that once your compound of interest reaches boiling point, the thermometer should stop or should stay level at the boiling point until your product of interest is distilled, right? So it's going to be vapor gases that eventually condense back to the liquid form, and you get a clean solution in your collecting flask, round bottom flask, or whatever that may be, right? So this is pretty much it for a simple distillation setup. Again, two important points: just make sure your thermometer bulb is below the condenser inlet, right? And make sure your water is flowing against gravity.